Hello to everyone and welcome to the second learning session at Cegeka, this time on Symfony 2 and its components. Today we'll be joined by two Cegeka teams, one from Leuven, Belgium and the second from Bucharest, Romania. Before we start, I wanted to thank everyone for participating and to carry on providing feedback at the end of these meetings. This way we can fine-tune the process as well as the content that we're exploring. We'll be having a look at what Symfony is, how we can use it, as well as why we would be interested in using it. This meeting will be content-packed as we're trying to explore a number of components and see how they behave, while also time-boxing it to an hour. If there is support for it, we can have additional meetings on more dedicated topics regarding Symfony later on. Our plan today is to cover the following: a brief introduction of Symfony, the people behind it, and what makes it special. We'll then have a quick look at the key features of Symfony and what makes it a nice alternative for your next project. We're going to then use Composer to install Symfony, and we're going to talk a bit about managing our dependencies through Composer before we move on to environments and basic components. We're then going to start really looking into Symfony by creating a new bundle and building a basic Hello World application. Now, database interaction is very important, so we'll be looking at how we can create a product entity using Doctrine. By the way, an entity is the equivalent of the business object. How we can leverage the power of Symfony and Doctrine together in order to generate a CRUD interface for us very quickly, for example. And finally, we'll be looking at generating a Doctrine migration ourselves. At the end of the meeting, we'll have a couple of minutes for feedback and questions. So let's jump in with a quick history of Symfony. Symfony is a PHP web framework for MVC applications, which was first launched in 2005 when it carried the name Sensio Framework. Development has been done by Sensio Labs, a French software development company, and the project is being led by Fabien Pontessier. The current version is 2.3, which is the one that we'll be working with today, and it was launched in June of 2013. Now is a very good time to start learning Symfony, as 2.3 is a long-term support build, and it will be maintained until May of 2016. Symfony aims to speed up the creation and maintenance of web applications. It features a bytecode caching mechanism so that there is minimal performance overhead, and is created from the ground up to allow for building enterprise-level applications, giving developers full control over the configuration. In terms of other open source packages, it integrates with Doctrine and Propel, both are OREMs, PHP unit, which is obviously a testing framework, Twig, a templating engine developed by Sensio Labs, which works very well, and SwiftMailer, which is a mailer library. A lot of big companies already use Symfony, but amongst the most notable ones are Askit, Delicious, Yahoo Bookmarks, Dailymotion, OpenSky, which is a CMS, eRepublic, EasyPublish, and then you have PHP and Drupal, which in version 8 already integrates a part of Symfony. Now that we've seen a bit about Symfony, let's try getting it installed on our own system. Symfony can be very easily installed via a single command if we run our dependency management for Composer. Composer is a dependency manager tracking local dependencies of projects and libraries. This means that any third-party libraries are automatically fetched when the environment is updated or configured for the first time. This also means that the source code of your third-party libraries can easily not be included in your project version control. Composer is fully integrated into PHP Storm 6 and IntelliJ. Now, Composer itself is hosted on GitHub, so let's pay them a little visit and see how we can install Composer on our own system. So if we go to the Composer website, which is right here, if we scroll down to the installation usage portion of the guide, we'll see a one-liner for downloading composer.var, which is a PHP archive. So let's try and go ahead and download it. We'll just open up a terminal, clear the screen, and we'll run the one-liner that we got from the Composer website. And that's it. Composer has been successfully downloaded to our computer. Note that we required curl in order to do this statement. And now if we look over here, we can see composer.var. We can even run it PHP composer.var. Great. So we have a recent build of Composer, and what we want to do now is that at the moment, so at the moment, Composer is not globally accessible. That means it lives inside the folder. So what we need to do is that we need to move it to user local bin. This way we can access it from anywhere, and we only have a single version of Composer installed on our system. So let's go ahead and move that and do that. Let's clear the screen. Let's move Composer to user local bin /composer. Input your sudo password, and now if we just type in Composer, you can see Composer is now globally accessible. Now, if we want to get Symfony, it's very easy if we're running Composer. We'll just indicate that we want the standard edition of the Symfony framework, and Composer will handle the retrieval of all our dependencies. Now, this is just, again, as I've said, a single one-liner to download Symfony. So Composer, create project, and then we're going to indicate that we want the Symfony framework standard edition, and then we're going to give it a project name, a folder name, if you will. Let's call it learning session 2. Okay. Now, if we hit enter, we'll see that Composer has already started downloading all of the dependencies that we need. So I'm just gonna briefly pause the video here while all of the dependencies are downloaded. Okay, all of the Composer dependencies have been downloaded, and now as part of the configuration of Symfony, we're going to be asked a couple of questions to help configure our project. Now, this is all done in an interactive console, and this should help with setting up our project. So let's just go through the fields here. Database driver, we're fine with MySQL. Database host, localhost is fine. Port is fine. For database name, let's call it learning session. That's fine. Database user, root, passwords, we don't need to fill that in just now. Mailer transport, we don't need any of the mailer configurations at this stage. Locale, English is fine. And this is a secret token, but we don't want to get into that just now. Okay, if we hit enter again, there we go. Symfony has been installed. We've downloaded all of the dependencies that we've required for it. Now our application is correctly configured, and everything that's left is to boot up the framework in our editor. Once we do that, we're going to have a look at the composer.json file to understand exactly what it is that Composer did over there. What dependencies did it bring, and if we ever need to add our own, how do we do that? So let's go to PHP store, open directory. Okay, learning session 2, because that's our project. Okay, and you can see that PHP Storm is integrated with Symfony, so we can just do that. And there's also another plugin which you can use, which is called the Symfony 2 plugin, and this you can also use that. It's very good. So if we open up composer.json, over here you can see the package that Composer just downloaded, which is Symfony Framework Standard Edition. It's licensed under MIT, it has a description, and here's where the first important part in the composer.json file is. So we're gonna have a set of requirements for this. For instance, we're going to be downloading the Symfony framework. Yes, the Framework Standard Edition package of Symfony does require Symfony. We'll also be downloading Doctrine REM and the Doctrine bundle, Twig, Ascetic, Swift Mailer, Monologue. all of these come bundled in the Framework Standard Edition, which is a package encompassing some of the features of Symfony. Now, in terms of scripts, we also have some post-install and post-update commands. And these scripts will just be run either after the first installation or after updating our Composer dependencies. So what's the deal with Composer? Why are we doing all of this? Well, for instance, if Doctrine release a new version, so currently, let's say that we have 2.2.3, right? What if Doctrine released 2.2.4? Well, in that case, obviously you'd have to go svn up or git pull that one particular repository, and a lot of things could go wrong. But with Composer, it's pretty easy. We just go into the project and then we run Composer update. And this actually just goes through every single one of that dependencies and make sure that we're running on the latest version. Okay, Composer being slow as ever. Okay. So those are all of the steps that you need to actually get Symfony on your local computer, your development machine. Now we're going to start looking at the components that Symfony has and the idea behind the environments, because you can already see over here it says clearing the cache for the dev environment with debug set to true, and we're going to have a look at that and see how it works. Okay, so let's have a look at the environments. Symfony has 3 environment scopes: dev, test, and prod. Dev is used during development. It features a profiler which comes up on every page, some better exception explanation, as well as the fact that a cache is recreated every time we make a request. The profiler which I'm talking about is basically just a toolbar at the bottom of the page where you can see how many database queries were made, what were the get and post parameters, a lot of very useful information for debugging. Now the test environment, that's used when testing with PHP unit, and it features the ability to load the custom database. So for instance, running integration tests, we want this to be done on a separate medium, and Symfony comes bundled with the power to do that. Functional testing is also running in the same mode. Production is used for actually running the project in production mode. It is very fast because the bytecode cache is instantiated and we have very small performance overhead. Important is the fact that the cache must be pre-built and will not be remade unless specified for a manual command. So what this means for us is that if we deploy a new version of a project to a website, we must recreate the cache, or else everyone that's visiting the website will still just see the old version. Now, let's also look at the folder structure in Symfony. Let's bring up PHP Storm. This is the Composer file that we looked at previously. And first off, we'll do a brief exploration and see exactly what the purpose of each folder is, and then we'll go into them in more detail. So we have the app folder, which is used for application-wide configuration, some utilities, and some data. We then have the bin folder, which is used for various scripts related to the project. The CRC folder, that's going to be hosting our actual application code, so all of our files. The vendor folder, this keeps third-party dependencies, which we've retrieved via Composer. You may remember seeing a message about that. Now, the web folder, this holds assets, which are sometimes split up into bundles. So images, CSS, JavaScript, that kind of thing. So let's have a small look into them. So we've got the application folder right here, app folder, and this has a couple of files. For instance, we have the autoloader over here, the bootstrap file, the check file, which is basically a script that's run to tell us, yes, Symfony is correctly installed. The console, script, I guess, which we'll be using a lot to generate bundles, to interact with Doctrine. It's Symfony's gateway towards all that functionality. We also have the PHP unit file, which is configured to run PHP unit for a typical Symfony project. We have the cache, which over here we can see is just for the dev environment at the moment, but you know, it's gonna create one for each individual environment. So for instance, if we're gonna run the application in test mode, it's gonna create a test folder and keep that cache in there. The logs, which again, our environments are separated into environments. The config, this is very important because in this folder we can keep application-wide configuration. So for instance, we can, by the way, Symfony uses the YML format for defining configuration, validation, mostly anything to do with parameters. So over here we can see, you know, the secret, the default locale, what templating engine will we be using, do we enable CSRF protection, you know, configuration related to Twig, aesthetic, and even Doctrine. If we look into the parameters file, we'll actually see that this is the file that was auto-generated during the composer install. So that interactive console that we received, this is the data that we actually sent in. And this is the template that interactive console was made for. Now, routing, we have nothing in here just yet, but we'll explore it a bit later. And finally, security. Resources, the only relevant thing that we need to know for now is that our basic template is in here. So this is a Twig template. You can see it has all of the traditional components of an HTML template, like the doc type, HTML, head, meta information, title. You see, these are Twig blocks. We'll get to them soon enough, but this is how it all looks. And think of it, oh, this is a template, and you know, we've got this block over here, and basically in each of our subsequent templates, we're just gonna be kind of adding the body content into the template. That's where we're looking at. For bin, we've got Doctrine and Doctrine PHP. They're used for console commands and that kind of thing. CRC, this is where our application actually lives. At the moment, Symfony has already generated some code for us. It's even got tests. It's got dependency injection. It's got 3 controllers already configured for us, forms, and various other things. Now, this is perhaps something that you could look into in your own time. We'll just end up deleting it and creating our own, because I think that's more important. Vendor, we can see all of the third-party libraries that we wanted to have. So Symfony, for instance, there it is. Twig, extensions, yeah, there it is. Extensions, monologue, you know, everything else is in there. Now for the web, we've got robots, favicon, configure, htaccess, all of that, and 2 very important PHP files. We've got app_dev.php, which is what we'll be using to run the dev environment, and app.php, which we'll be using to run the production environment. I guess that the last really interesting file here is travis.yml, which holds some standard configuration for the Travis continuous integration system, which is pretty awesome, by the way. Travis initially used to only do continuous integration for open source projects, but now they also have a dedicated plan for, you know, private repositories and that kind of thing, and it also integrates very well into GitHub. And basically with Travis, we just say, oh, okay, please test my application for PHP 5.3.3, 5.3, and 5.4. And before we run the script, we just do a Composer install to make sure that we have the latest version of Composer, and then we run PHP unit on our folder. It's nothing magical about it, but it can be configured quite a lot, and we'll be able to have a look at that maybe in the future. Okay, so that's the folder structure for you. Now, I guess that it's very important to understand this bit about request response, because the entirety of Symfony is kind of based around this concept. PHP developers are used to making all sorts of tricks and small little hacks to get around various constraints. But Symfony aims to help with all of these problems. It's important to understand the fundamental model behind it. Symfony expects to receive a request from one computer to the server and return a response. That's the basic idea. Everything is built around this. And, well, oddly enough, HTTP is built around this. The framework allows us to do something global for any type of request, or do something special in the event that we have a GET request, a POST request, batch, put. Symfony actually has support for all of those methods. They can be easily configured. In terms of response, we could return HTML, JSON, XML, and a JPEG, whatever we want. And this is important because it's very well and very fundamentally built into Symfony. So, for instance, if we're going to be returning a JSON response, that means, okay, yeah, the content type will automatically be set, content length, all of that. We're not actually going to return an HTML with some text in it that looks like a JSON. We're actually going to be returning a JSON response to that. And depending on the request, the response can be in English, French, or whatever locale the user has assigned. So our HTML or our XML response could be, again, specific to a particular format. Now that we've seen the organizational format and know a little bit more about how everything is managed, let's look at making our first bundle in Symfony and getting our hands dirty with the code. Okay, so let's make sure that our application is really working. First step to doing that would be to create a virtual host, reload Apache, and then just show how it works. So let's open up a terminal, and I'm going to go into etc Apache sites available. Now, just gonna copy one of my previous configurations, but I'll show you what's in it anyway. Let's call this learning session 2. Okay. Okay, so we have a server name, which was set to learning session 2. Don't need the server alias, and yeah, we'll just set this folder structure. Please notice that it actually goes into the web folder, so the folder that has all of the assets. And if you remember over there, actually we can bring it up in PHP Storm over there. We've got these two files, app.php and app_dev.php, which are used in order to kind of say, okay, app.php is for the production environment, let's try and simulate that. App_dev, that's for development environment. Okay, so let's learning session 2. Okay, that seems fine. Okay, let's also edit the host file. Dev that learning session 2. Okay, and now we just need to go into var www and make a symbolic link over here to projects, and I think it's learning session 2. Yeah. Okay, that should be enough. Great. Oh, of course, we should also enable it. Okay. Now, okay, go away. Learning session. Okay, yeah, that's actually what we expected to have on there. So if we go to app dev, yeah, you can see over here in the development view, yeah, that the application has been correctly configured. And why does this happen? Well, it's quite easy. It's because there's no route configured for the slash, so that's why we're seeing that. If we go to configure, yeah, you can actually set all of those fields that you couldn't do before, that were used in the interactive console at the beginning. Okay, so that's great. We already have some code on here, but as I've said, I really want us to build our own thing. So I'm going to start off by removing the demo application that we have. And this means basically just deleting this folder initially. Go away. Okay. Now we're going to go into routing dev. We're going to delete its resource from here. And finally, in application kernel, which is a very important file, this is one of the main points of entry to our project, and it does the loading of the bundles that we need. So you can see here that some of them have been pre-configured for us, the ones over here. And we can see that we can also define particular bundles for particular environments. So for instance, if we're running in the dev environment, yeah, we've got access to the demo bundle, the web profile, the the generator bundle, this kind of thing. Just going to remove Acme from there, and now we're going to build our own system. So everything in Symfony, code-wise, lives inside of a bundle. The bundle is an isolated system containing all of the information and resources required for managing the operations in that subsystem. So an example would be this, having an admin bundle, shop bundle, website bundle, and API bundle. The admin does everything to do with content, editing that. The shop does everything to do with cards, maybe payments. The website does everything to do with presentation, services available, and we'd also have an API bundle to expose to other devices or something like that. Now, we're going to create a new bundle over here, and again, I need to stress that this is something that's isolated. It has its own assets, it has its own routes, it has its own services that it uses, it has its own tests. So we're going to create one of these now, and it's really very easy to do one. We just run a single command, which is through the console script. And before I mentioned that in the app folder we've got the console script, which we use to generate new content or run Doctrine and that kind of thing. So let's see, it's php app.console, let's see, generate bundle. And now we should see another interactive builder from Symfony. It's going to ask us for a bundle namespace. I'm just going to call it Cegeka Learn Symfony. Cegeka Symfony bundle. Okay. Now it's going to recommend a name, and we're going to be referencing this name in a lot of places. I usually just stick with the defaults because I really like them. It'll say that the bundle can be generated anywhere, but that it thinks this directory is fine. Yeah. Which format do we want for routing and all of that? We'll go with YML. It can also generate some code snippets for us. You could see the code being generated in the demo, but we really don't want that. Okay, so finally, if we confirm generation, yes. Okay. Remember how we had to delete the demo bundle from the kernel? Well, this tool right here, the interactive console, is also going to add our bundle to the kernel, so just to make sure that that's in there. Now, it'll also ask us about routing and if it wants to create a basic routing importer for us. We're gonna go yes with that. I'll show you just in a second what that means. So if we jump back into PHP Storm, in CRC, you can see that the Cegeka folder has been named. We now have a Symfony bundle that has 4 folders: controller, dependency injection, resources, tests. And there's also the Cegeka Symfony bundle right here. Just gonna close everything now so that we can look at this. It has generated a default controller for us. We're gonna go ahead and delete that because we don't want it. Whatever. We don't need to actually delete it for now. I'll just leave it in. Dependency injection, this handles that component. Resources will keep our configuration files and our views in here. Tests, that's actually going to keep the tasks that we have for controllers, entities, or anything else. Okay, so we've created a bundle, and we've also made a change in application kernel. You can see that our bundle is now also loaded on here. If I remove this, we won't actually have access to it in the application, which is not what we want. And it's also added a line in the routing.yml file over here. Basically, it says, yes, we have this bundle. It has its own routing system somewhere internally. Just go and read the information from there. So if we now go into Cegeka Symfony bundle resources config routing, yeah, you can see that we already have a route defined over here. We're actually going to wipe this because we don't want to do anything without understanding what it is that we do. Now, next step would be to create a hello controller. So what this means is that we would like to display a hello world message when we visit the hello page /hello. And in order to do this, we're going to create a new class in the controller folder, which we've just seen. Right over here. We're then going to extend the Symfony controller class, which is a component class. We're going to create a hello action method. We're going to return a new response with the hello world message. And finally, we're going to set up a route for it so we can see how content is directed. Okay, so first step is to create a new class and controller. When it comes to static pages, I always like to go with content controller. I think it's a fitting name. We have the namespace that's been automatically set for us, and we said that we want to extend the controller class from Symfony, right? And that's this one right here. Okay, by extending this, we get access to some very nice helper methods, and I'm going to talk about them in just a bit. Now, we want to create in the traditional Zend way a hello action. So let's just go ahead and do that. Public function hello action. Okay. And we want to return a new response containing some text. Response, that's also a Symfony class, and we're going to reference it in just a second. So basically what we want to do is that we just want to return hello world. We don't want to do anything else. All of our logic sits in the controller at this point. And it's this one. We can also see over here, you can change the status of the response, the headers, so you can customize anything about this response. It's actually the base class that's gonna get called whenever we do a JSON response or a file response or anything else. It'll actually go through here. Now, what did we want to do? So we wanted to create a class in the controller folder. We've done that. We wanted to extend the controller class. We've done that. Create a hello action method and return a new response with a message. So now we just need to set up a route for it. Let's go ahead and do that. So as I've said, the first thing that's going to get loaded is this routing YML file in the app folder. And that in turn is going to load up the routing from our resources folder right here. Now, if we go inside of it, we'll be able to create a new path. So let's just say hello. It doesn't need to be more than hello, actually. Okay, we're gonna say, okay, path to hello. And we're gonna say that it defaults to the controller. Let's say Cegeka. Okay, and helpful autocomplete over here. So you can see that when we're referencing controllers or actions, it's going to go and take this name right here that we chose for the bundle, Cegeka Symfony bundle, and then is the controller name, which is content, and then hello. Okay, so we're just going to use that. Now, if we go back to our application and just go to hello, yay, we can see hello world. And that's great because that's exactly what we wanted to do. Now, obviously, this is all going strictly for the controller, but in real life, we want views, we want the ability to process the information over there, prepare data for views, you know, get them from the database, all of that. So our first step is to now try rendering a view, and this is done in Symfony by default using either Twig, which again is enabled by default, or using PHP. We're gonna have a look at Twig and see how that works and just the sort of power that you have with it. And in order to do this, we'll be creating a new folder under the resources views folder with the name of our controller. We will then create a Twig file in there, and finally we're going to call the render method in our controller method. So let's see, we should already have a view defined. Yeah, there it is for default. We're gonna create one for content, which is our controller, and then we're gonna create a new file, which is hello.html.twig. Great. Inside of it, we're going to say hello world, which is the message that we want to display. Let's add something to it so that we know it's different. Now, remember how I said that when you extend the controller class, you get access to some helpers? Well, we're going to experience one of the first ones. We're gonna say, okay, return this render, and we're going to be rendering Cegeka. Okay, again, helpful autocomplete coming in there for me, but again, we're gonna be doing this, hang on, without the autoloader. We're gonna go and say Cegeka Symfony bundle, then it's the folder and our file is in, and then it's hello.html.twig, and our plugin confirms that that is in fact valid. Okay, great, so let's see how it works. So if we go back here, you can see hello world is now a title. It's much bigger, obvious, but we can obviously see that it's just a title. It shouldn't be like that. It should be incorporated in a template. It should have meta information, all of that. So we should also think about, you know, leveraging the power of Twig a bit more and seeing what we can do there. So we want to load the parent template and populate its content area with our message. We then want to extend the base template that we had via the Twig extends method, and we want to add content from Twig in a block body tag. We'll see what that means in just a second. So let's go to our Twig template right here, and let's open up the base template. And going back to this, you can see that it has a title, which is indicated by the block. Blocks are essentially separators, which can have content, but which can be overwritten by the other Twig files that inherit, you know, this parent template. So, for instance, if I would be able to overwrite the title on any page, right? Because I'm inheriting from this. I would also be able to, you know, change any style sheets, or I would be able to use all of the style sheets that are available on any page and add some of my own. I'll show you how in just a second. So we can see that there is also a block body, which is there specifically to allow for content to be added. So in order to do that, we first need to extend the base HTML twig. Okay, notice the two double points. That's because it doesn't belong to any bundle, which was the first part. If you remember, for us it was Cegeka Symfony bundle, and then it belonged to a controller, but that's not the case over here, so that's why we've got the 2 points. And finally, we just want to say, hey, this is a block body. Okay. Okay, there we are. So now if we refresh, you can see, oh, it looks completely different. We even have a profiler over here. So the content looks obviously very different. We have meta information, a title, all of that. And you can even see the Symfony toolbar, which is what I've said, a very, very powerful tool that allows us to have a lot of debug information. So for instance, over here, you can see, yeah, this is the memory usage, or the fact that this user is not authenticated, the response code that it had, the number of database queries, and the query time, the total time that it took to transmit this information. You can even go more in depth and see things like request. What was it? What was the PHP session ID? You know, what was the user level? All of the information that actually gets sent out, which is very good. Emails, you know, it can monitor all of that. Logs, again, you can see everything about it over here. Events, exceptions, everything, which is of course very powerful. Okay, now to not get carried away, let's come back here. Okay, so yeah, that was all right. We now understand a bit about Twig. We know that it has a way of extending templates. We know that it has a way to include more data, to change it. And we also know that our controller can respond and just render a Twig template now instead of just regular text. But we would like to know, how exactly can you pass a get parameter to one of our controllers? And we're going to have a look just at that. So the first thing is to bring it up in the PowerPoint. Great. So we want to pass a get parameter to the method and change our template so that the name that is passed is displayed in the template. In other words, instead of hello world, we want to say hello Peter or hello Sebastian. Okay, and there's 3 steps that we need to do for this. We need to change the routing information so that we say, okay, you're now going to expect a parameter over there. We're then going to add the parameter to the method signature, and then we're going to pass that method to the render. And finally, we're going to change the template so that it just displays that variable. And this will understand even a bit more about Twig. Okay, so first step, change routing information. Of course, we go into our bundle, into the routing file, and over here we just add name. Okay, great. Now we go to our method and just say, yeah, I'm just gonna receive a name, and that's everything to correlate it with a get parameter. Finally, we're going to send in an array to our Twig where the name is name. Okay, so let's see, if we go and type in hello Petre, does it work? No, it doesn't work, but we haven't received any failures, which means that our route is correctly configured and that our method was called correctly. Okay, so we just need to change hello over here. And here's Twig in Power. If you want to display a variable, that's it. And even more than this, Twig offers a lot of filters and templates. So for instance, if this was an HTML code, I could have, displayed it raw, or I could have encoded it. I could have made it spaceless. There's many things that are available out of the box from Twig, and I really recommend that you have a look on that. And if you can't find what you need, then you can just write your own, which is even better. Okay, so there it goes. It says hello Petre. Let's add the exclamation mark over here in the end. Let's also make it say hello Mihai. Okay, great. Okay, now let's choose someone from Belgium too, because otherwise I'll be upset. Okay. So we've seen a bit about the controller and the view layer, and how just a very overall view on how they work. Now the controller receives the data for the request and handles the response for it. A response is either HTML or a Twig template, or perhaps a JSON response, or whatever we want to. And now we're going to explore the model layer and see how Symfony's components are split up there, while also understanding a bit about the power of Doctrine. And just because we're talking about JSON responses, let's kind of comment this out and just go ahead and return a new JSON response, and we'll give it an array of data. Name, actually just go with name and name. Okay, and if we now refresh, hey, there we go, it's a JSON. And if we look in the content type for this, I probably won't be able to do it. Yeah, there you go, it's application JSON, exactly what I was talking about a bit earlier. And you can see how easy that was. I just passed in an array, nothing else. This is the sort of power you get in Symfony. A lot of things are very easily configurable, and I'm only very briefly scratching the surface here. Okay, so now onwards towards Doctrine. Since we're short on time, I have about 10 minutes to go. I'm going to spend 5 minutes on showing you how to create an entity in Symfony and expose a CRUD interface for it, and the next couple of minutes on how a more developed Symfony application looks up close. Using the power of video editing, I've already created the product entity, or you can call it a business object, so let's have a look at it. This is it right here. In its basic form, it's just a class that has 3 fields: ID, name, and price. You can see the class itself is full of annotations, which let Doctrine know how to generate the class. For instance, this is the table name. We specify that it's an entity. You can see that this is an ID and that it's a column of type integer, that the generation value for this is of the auto strategy. Basically, that just means auto increment. We have a column that's a string, and that has a length of 160. And a price that's just an integer. In order to interact with the class, we're going to need getters and setters for it. And then we're going to create the database and make sure that it's at its most recent form. And Doctrine is just going to take this class and transform it into a database table which we can use. So, as I've said, the first step is just to generate the getters and the setters for it, and we're gonna do this by running the Doctrine generate entities command, and then we're gonna specify no backup, which means don't create a backup of the PHP class that we have, and there it goes. And this has created getters and setters for all of our fields, and we use the same annotations to create very complicated joins and many-to-one, one-to-many, everything else we do via these entities. And this gives us a very direct translation between a database table and a PHP class. The next thing that we want to do is that we want to create the database. So we're just going to run Doctrine database create. the next step is to say, okay, I want you to bring the database up to the latest version. So we're going to go Doctrine schema update -- force. And it's going to say, okay, we're at the latest version of the database. Now, if we quickly go into MySQL Workbench, we can see that our database has been created, that we have the table, and that over here we have a product. And if we look at it, it features an ID, a name, and a price, and we can alter it as much exactly as we feel free, exactly as we want to. Now, let's just run single command Doctrine generate CRUD. And this will actually generate a CRUD interface for us. We need to give it the name of the entity, and that's Cegeka Symfony bundle. For the product entity, would we also want write actions? Yes. We're gonna determine the format, which is YML, the routes prefix, and yeah, confirm generation. At the end, it's going to give us a small snippet, which we need to include into our routing, just over here. Okay. And now, if we go into /product, yay, we can see an interface that allows us to create a new entry. Let's give it a name of test and the price. That's created the entry. We're free to edit it or go back. And there we can see it. Let's create second test. Just give it a price, and you can see they all exist over there. We can hit show on the first one, delete it. It's the full CRUD interface. Now, here's something even more interesting. With the database profiler, we can see exactly what happens in the backend. So we can see, oh yeah, for this connection, I had to do a select statement, and I can see that statement right here. I can even have an explanation and see how complicated the select statement was. And we can see all of the mappings and everything else that's gone on in here. And that's very powerful. Now, I'd like to show you how more developed Symfony project looks like, just so that we can see what happens when you leverage all of this power. So I'm going to show you an open source project that I'm currently building, and I'll just go through a couple of things very quickly now that we understand the basics. So you can find the project over on my GitHub page, or I've opened it up in PHP Store. Great. So the first thing is entity validation. That's always something complicated to do. Well, in Symfony, it really isn't. If we run through the entities idea, for instance, I have an entity here that's called account, and I'm just setting some constraints for it. So I want the username to be unique, the email to be unique, and an API key, which is something else, to be unique. And then I'm just going to say, oh, in its properties, I want the username to be not blank, not null, to be of a type string, and have particular length. And why is this a fast way of doing things? Because if I want to go in and register a new account, then I have access to a validator service, which is a singleton that's used in order to validate pretty much anything. And I'm just going to call validate for that entity. And this is going to tell me, oh yes, it's a valid entity or not. And the idea is that Doctrine will actually be over there, and invalid data will never be entered into your database. If you say the username is unique, it will remain unique. Now, in terms of testing, Symfony 2 is super powerful. It has, besides the fact that it integrates very well with a BDD framework called Codeception, it features all layers of testing, and it has a lot of support for them. For instance, unit testing, that's very basic. Integration testing, which is a bit more complicated. This is a service, for instance. Well, let's scroll up. Okay. And integration tests, they actually run on a separate database, which I've specified here. I said that I want the database name for the test scenarios to have an underscore test at the end. And if I go into my SQL Workbench, I can see that, for instance, for Scrum Manager, I also have Scrum Manager test. And that's actually the database that's being used for Jenkins and Travis and all of the other continuous integration things. Okay. And as I've said, it's very easy to validate an entity and see everything about that. Now, continuing on with testing, we also have end-to-end testing. And just as a very quick example, look how easy it is to register a new account. Hang on. Yeah, over here, we're going to create a new client. Go to API test screen account register. Fill in a form. So I'm just going to say form username is this and that and that. Then we're going to assert that we have a successful response, and then we're just going to log in. And this is all, it actually works without any more setup, nothing else to that. Now, in terms of model structure, that's something that needs to be complex, because when we're talking about enterprise applications, we want layers, and we want to have an architecture that can sustain anything that we're building. So for Symfony, we have, and I'm going to be creating parallel to Zen framework. For Symfony, we've got entities, which are basically business objects. So this is an entity with just a couple of fields and then getters and setters. We then have repositories, which are essentially the mappers. And basically they just handle, translating two entities, getting arrays, making entities out of them, that kind of thing, saving information to the database. Finally, we've got services, which enable us to do many more things. In this case, we're going to create an account. We're going to set some default values for it. We're going to validate it. And based on this, we're going to create it or not. Another service would be the JSON service, which doesn't have anything to do with the repository. It just decodes or encodes information into JSON, and it triggers a successful response or an error response otherwise. Controllers are very thin. So this project is basically an API at this stage. So for instance, to register a user, I just get some request data, I call the account service, and based on that, I return a response. And this could probably be refactored to be better. So it's very, very small, very, very thin. That's the idea behind controllers. Thin controllers, fat models. Now, I've shown you a bit about how to update your database to the latest version, but Doctrine actually features migrations, which allow us to go into any point in time that the database was stable. So for instance, by running this one migration, I would be exactly after the first initial creation of the database. Over here, I would be after I've changed some columns. And you can see how Doctrine actually goes in and creates a migration to upgrade and also to downgrade, because that's what migrations actually mean. Finally, some words about routing. You can actually configure it so that it responds based on format. For instance, over here, this is a method that will only respond to a post statement. And there's many things that you can do over there. For instance, when I'm actually loading the routing information from the bundle in the routing.yml in app, I just specify a prefix, and all of the routes within that actually have a prefix. And think how useful this is if you're designing an administration interface or an administration bundle that can be used with any system. That's it for the presentation. I hope that this overall view on Symfony was worth your time and that you now understand a bit about the power behind it, given that we just generated a CRUD in 2 minutes. Obviously, there's so much going on and we're very much just scratching the surface. It's very powerful behind it. both in terms of validation, security, optimization, everything. Now, if you'd like to know a bit more about Symfony so that we have a more dedicated meeting with a bit more code, let me know. And otherwise, now I look forward to the feedback from both teams. Okay, bye-bye.